Hello grade 11 American System, this is Mrs. Nancy. Today I'm going to continue section 17.1, the flow of energy. Units for measuring heat flow. So, heat flow is measured in two common units, the calorie and the joule. You heard of someone exercising to burn calories. During exercise, your body breaks down sugars and fats in a process that releases heat. For example, in breaking 10 grams of sugar, your body releases the same amount of heat that would be released if 10 grams of sugar were completely burned in a fire. So, a calorie is defined as the quantity of heat needed to raise the temperature of 1 gram of pure water 1 degree Celsius. And the word calorie is written with a small c, except when referring to the energy contained in food. The dietary calorie, written with a capital C, refers to the energy in food. So, 1 calorie equal 1 kilocalorie equal 1000 calories. The joule is the SI unit of energy. 1 joule of heat raises the temperature of 1 gram of pure water 0.239 degrees Celsius. So you can convert between calories and joules using the following relationships. 1 joule equal to 2390 calories and 4.184 joules equal 1 calorie. Heat capacity and specific heat. The amount of heat needed to increase the temperature of an object exactly 1 degree Celsius is the heat capacity of that object. The heat capacity of an object depends on both its mass and its chemical composition. So, the greater the mass of the object, the greater its heat capacity. So, different substances with the same mass may have different heat capacities. Let's take an example. A 20 kilogram puddle of water may be cool, but a 20 kilogram sewer cover may be too hot to touch. What does this mean? This illustrates how different heat capacities affect the temperature of objects. If both the water and the iron absorb the same amount of radiant energy from the sun, the temperature of the water changes less than the temperature of the iron in the same amount of time. Why? Because the specific heat capacity of water is larger than the specific heat capacity of iron. So what's the meaning of specific heat? The specific heat of a substance is the amount of heat it takes to raise the temperature of 1 gram of the substance 1 degree Celsius. So, open your books page 559 and look at table 17.1. It gives specific heat for some common substances. Calculating specific heat. So, to calculate the specific heat of a substance, you divide the heat input by the mass of the substance times the temperature change. So, C equal Q divided by M times delta T. Q is heat, unit joule or calorie. M, mass, unit grams. Delta T, it represents the change in temperature, and it is calculated TF minus TI, where TF is the final temperature and TI is the initial temperature. Units of specific heat are joule per gram times degrees Celsius or calorie per gram times degrees Celsius. Sample problem 17.2. The temperature of a 95.4 gram piece of copper increases from 25 degrees Celsius to 48 degrees Celsius when copper absorbs 849 joules of heat. What is the specific heat of copper? Given mass of copper equal 95.4 grams, delta T, which is T final minus T initial, equal 48 degrees Celsius minus 25 degrees Celsius, and the answer is 23 degrees Celsius, and Q equal 849 joules. So start with the equation for specific heat, C equal Q divided by mass times delta T. Then substitute the known quantities into the equation to calculate the unknown value C of copper. So the answer is 0.387 joule per gram times degrees Celsius. Number 3. When 435 joule of heat is added to 3.4 grams of olive oil at 21 degrees Celsius, the temperature increases to 85 degrees Celsius. What is the specific heat of olive oil? We write the given. Mass of olive oil equal 3.4 grams. Delta T, which is T final minus T initial, 85 degrees Celsius minus 21 degrees Celsius equal 64 degrees Celsius, and Q equal 435 joule. So we write the heat capacity of olive oil equal Q divided by mass times delta T equal 435 joules divided by 3.4 grams times 64 degrees Celsius, and the answer is 2 joule per gram degrees Celsius. How much heat is required to raise the temperature of 250 grams of mercury 52 degrees Celsius? Specific heat of mercury equal 0.14 joules per gram degrees Celsius. Given mass of mercury 250 grams, delta T is equal to 52 degrees Celsius, and specific heat of mercury equals 0.14. So we start with the equation for specific heat, rearrange to find Q, which is equal to C times mass times delta T equal 0.14 times 250 grams times 52 degrees Celsius. The answer is 1820 joules or 1.82 kilojoules.